I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground.
That's one small step for man, one giant leap for mankind.
It was really dramatic. Rough terrain, cratered, hilly, and I kept thinking, nobody's ever been here before. I'm on the moon.
Hello everyone, welcome to Living History and the second instalment of our special episodes commemorating the 50th anniversary of the Apollo moon landings. Last week we spoke to Brian Odom, a historian at NASA's Space Center in Alabama, and if you didn't listen to that interview, go back and look it up. It was absolutely fascinating. But we should remember that the Apollo landing wasn't just about America. There was also very strong involvement from Australia, and it's something that people perhaps don't know very much about. Australia's very important involvement in the Apollo program, and particularly Apollo 11, the Apollo mission that landed on the moon. So today I'm speaking to John Sarkissian, who is a scientist at the CSIRO Radio Telescope at Parkes, the famous dish that we've all seen in the movie that beamed signals from the moon during the moon landing. And it was wonderful to speak to John about the work that they do at Parkes and the history of this magnificent piece of scientific equipment and the contribution Australia played to the moon landings. So let's hear from John about the radio telescope at Parkes. John, thanks so much for joining us. It's fantastic to be talking to you live from Parkes.
Well, it's a pleasure speaking with you too, Matt, and I'm really looking forward to it.
Tell me about this fantastic dish that's out there. I mean, everyone's seen the movie. We've seen incredible photos of this huge piece of scientific equipment, and as they said in the movie, in the middle of a sheep paddock. Tell us a little bit about the dish. How long has it been there? Why was it originally built? What's it for?
The Parkes Radio Telescope has been described as one of the world's great research instruments. It was commissioned back in October 1961, and when it was built, it was only intended to have a lifetime of 20 years or so. But this year we're commemorating 58 years of operation. And the reason for that is because we've continually upgraded the telescope and ensured that it remains at the very forefront of world radio astronomy. The telescope, when it was built, was the second largest but most advanced radio telescope in the world. It incorporated many innovative design features that have since become standard on all large single-dish radio telescopes, and which is why it looks like the archetypal, radio telescope and tracking antenna and so on. From within just the first year alone, it made significant. The astronomers using it were able to make significant discoveries. So, for example, they discovered the magnetic field of the Milky Way galaxy. A few months later, they discovered or were able to pinpoint and realize the significance of quasars, which are the most distant known objects in the universe. And then later in that first year, Parkes tracked Mariner 2 when it flew by Venus, the first ever interplanetary space mission. Since then, the telescope's made countless discoveries. We're still doing great world-class science, still making discoveries that are totally reshaping and revolutionizing our understanding of the universe. It's essentially just a glorified radio antenna, 64 meters in diameter. And because it's so large, it's extremely sensitive. But because we use it to detect the radio emissions from the stars, we refer to it as a radio telescope. But whenever you say telescope to the general public, the first thing everybody imagines is something you look through, like Galileo's telescope, for example. But essentially, we're just a extremely sensitive radio antenna that's designed to detect and study the radio emissions from the stars.
So, John, it was built in 1961. This was at the height of the space race. Was the purpose of the radio telescope to assist with that space race, or was it for a whole range of scientific endeavours, of which space travel was just one?
That's right. It was actually Australia helped found the science of radio astronomy, because in the immediate post-war years, many of the engineers and scientists within CSIRO's radio physics laboratory. During the war, they developed radar for use in the Pacific Theatre. But following the war, the team was kept together, and they decided to try and investigate these mysterious hisses and noises they were hearing in their radar sets whenever the sun rose and so on. And so following the war, when they were free of all of the other wartime responsibilities, they devoted their time to try and determine what these other objects were that they were detecting. And very, very quickly, they were able to pin them down to sunspots on the sun, to extragalactic radio sources like colliding galaxies, supernova remnants, and so on. So very quickly, Australia established itself as one of the world leaders in the science. But very quickly, the equipment they were using, the old surplus wartime equipment, like the old Yagi antennas, similar to antennas that were similar to television aerials, they became obsolete after a few years, and they began to see, what should the next step in the development of radio astronomy be? And Edward Taffy Bowen, who was the chief of the radio physics division, he decided that the best all-round instrument to continue the world-class science at radio physics should be a large, fully steerable radio telescope. And so he found that he was able to get the funding to construct the telescope, have it designed to CSIRO specifications. And so subsequently, the telescope was built and commissioned in October 1961, and it became, at that time, the leading radio telescope in the world, the most advanced, and so on. But it had, as I mentioned before, it had so many innovative design features that even before the telescope's construction was completed, in 1960, NASA had approached the CSIRO and proposed including the telescope in its fledgling deep space network, which was an array of 3 stations that NASA was planning around the globe so they could keep continuous track of spacecraft at the planets. But the CSIRO knocked back the offer because they wanted to use it for radio astronomy, which is why it was built, so they could continue Australia's world-leading science in that. But the CSIRO did agree that whenever they required a strong, stable, reliable signal at critical moments in their upcoming missions, then the CSIRO would agree to support those missions. And consequently, the very first interplanetary mission, which was Mariner 2, when it flew by Venus in December of 1962, the Parkes telescope tracked the spacecraft as a test to see how well an instrument this large could detect the signal from such vast distances. The test was so successful that NASA decided that the next generation of antennas that they were planning, the large aperture antennas, would all be 64 meters in diameter, just like the Parkes telescope. And so consequently, the first of those big antennas was built in Goldstone in 1966, and then the next 2 at Tidbinbilla near Canberra and Madrid in Spain were built and completed in the early 1970s to complete the array of these really large antennas and so on. So Parkes not only contributed towards the missions, it played an extremely critical role in terms of the design and construction of the large aperture antennas in the deep space network.
It's absolutely extraordinary, John. I had no idea Australia was leading the way in this technology. Why was Parkes selected as the site for this antenna?
The original work that CSIRO was doing in radio astronomy was in Sydney. They had various field stations around Sydney. The most famous was at Dover Heights, over the cliff tops there, looking out over the Pacific Ocean, and they were able to do some of the groundbreaking work there, which is quite amazing. But when it came time to build a really large antenna, which was going to be many orders of magnitude more sensitive, then building it in Sydney was just not on, because the radio emissions from all electrical equipment, man-made equipment, radios and car ignition systems and any piece of radio equipment emits radio energy, would very easily overwhelm the extremely weak cosmic signals that the telescope is designed to detect. So they needed a site that was more distant, in a remote location that was free of radio interference. So they looked all around New South Wales. They found a site just to the north of Parkes, about 26 kilometres. That seemed ideal. There, towards the east, there's a small mountain range, the Harvey Ranges, that shield us from the radio emissions from the larger population centres further east, such as Sydney, Bathurst, Orange, and so on. So it was a very radio quiet area. And also, it was climatically, it was pretty good, because, as you could imagine, the Parkes telescope resembles a large beach umbrella. And just like a beach umbrella, when the wind blows, it puts a lot of force on the dish. Even a light breeze puts a lot of loading on the dish. And so you needed an area that had relatively low winds. It also needed to be geologically stable, so they didn't want earthquakes and anything like that. But also, they didn't want it to be snowing either, because, you know, if snow builds up on the dish structure, it can hamper operations and so on. And so for all those reasons, and in addition, it was about 5 hours drive from Sydney. So the engineers there could drive to Parkes, do their work, and drive back in reasonable time. And so for those reasons, Parkes seemed an ideal location. But the icing on the cake for choosing Parkes was that the local council supported it and actually offered to cover some of the cost of establishing the site, such as putting in the roads and the power and so on, which greatly helped in the funding of the telescope. And so that's how it came to be at Parkes. It was various reasons, but it was at the time, the primary reason was that they needed it to be free of radio interference, and this was a very good site at the time.
So you mentioned, John, that NASA were keen to include Parkes in their ground stations for their space missions. And in 1961, this was at the height of the space race, the Americans versus the Russians trying to get ahead in space. What was Parkes used for in those earlier space missions? Was it used at all, or was it only later in the Apollo program that it was used?
No, Parkes was used from the very beginning. Because for many years it was the most advanced radio telescope, and NASA was just planning and designing and building their array of antennas. The initial Deep Space Network had an array of 26-meter diameter antennas, or 85 feet, and they were actually modified radio astronomy antennas from the Bloor-Knox company in the US. But they needed the next generation, the really large antennas. And for many years, it was Parkes that was involved. In the Northern Hemisphere, the Jodrell Bank dish would track some spacecraft, especially of the Soviet missions, to alert the world as to what the Soviets were doing. But the very first mission that Parkes tracked was Mariner 2 at Venus in December of '62. And as I said before, it was the first interplanetary space mission. And the track was so successful that it resulted in NASA deciding to build their antennas of similar size and reasonably similar design. So it became the model for the big antennas. 3 years later, in July of 1965, Mariner 4 flew by Mars, and the big Goldstone dish hadn't been completed yet. So Parkes was called in to act as the big antenna in that network to ensure that the signals would come through. And consequently, Parkes was able to receive the first ever close-up pictures of the Martian surface, in fact, of any planetary surface, in July of 1965. So the scene was set. The astronomers had worked with the engineers at NASA. There was a good working relationship. And in fact, the first director of the observatory, John Bolton, in the 1950s, had gone to the US from Australia, from radiophysics, to introduce radio astronomy to the United States. They had been lagging Australia in those days, believe it or not. Australia was the world leader in it. The US was concentrating on nuclear power and nuclear energy and so on, and they felt that they needed to catch up in radio astronomy. So John Bolton was seconded to Caltech in 1955 to introduce radio astronomy there. Now, Caltech is where the Jet Propulsion Laboratory is, JPL. And it was JPL that was setting up the big antennas for the tracking networks. And so John already knew many of the engineers and astronomers and had worked closely with them. So when he became the director of the observatory in 1961, he was able to liaise with them very, very easily. In fact, engineers came to Parkes to study the telescope for 6 months. John had arranged it all. And so in those first tracks with Mariner 2 at Venus and with Mariner 4 at Mars in July of 65, there was already a very close, very good working relationship between CSIRO and NASA. So in October of 1968, John was visiting Caltech when he was invited to a dinner at the home of one of the engineers there, Bob Leeton, who was the PI, the principal investigator for the Mariner 4 mission. Anyway, during the dinner, John was asked if he could make available the Parkes telescope for the upcoming Apollo 11 mission, the first lunar landing mission. And so because human lives are at stake, both he and Edward Taffy Bowen agreed that CSIRO would support the mission. And so that's how Parkes became involved in that. Because it was the very first lunar landing mission, NASA wanted the most advanced, most sensitive, in fact, the best, radio telescopes and tracking antennas tracking the lunar module, especially for those few hours that the lunar module was on the lunar surface, because they weren't sure just how strong the signal would be or what the quality would be and so they wanted to ensure that the most sensitive instruments were receiving the signal. So Parkes became involved in that way.
Well, let's talk specifically about that Apollo 11 mission. Probably the most famous thing the dish has been involved in its lifetime. Let's also talk about the movie. I mean, everyone would have seen the movie that came out in 2000 about the dish from Working Dog. They did a great job, a very funny and a heartwarming movie. How much of what we saw in that movie was the reality of what was happening at Parkes during that Apollo 11 landing?
The film The Dish, which came out in 2000, is a wonderful film. I'll state that from the beginning. I love it. It's a very good-natured, warm-hearted film, which told the story in a slightly quirky manner, if you like, of Parkes' involvement. But the thing always should keep in mind, it's not a documentary. It was a film that took a little bit of artistic license in terms of the characters and the events and so on. But essentially, they took events that occurred at Parkes during Apollo 11, combined it with events that occurred at some of the other tracking stations, both for Apollo 11 and other missions, mixed it all together and exaggerated some aspects, made up a few others, and told the story that was loosely based on the events here. But they did get the gist of the story correct in that it was Australian facilities that received the famous Apollo 11 moonwalk TV and relayed it to 600 million people worldwide, one-sixth of mankind at the time. And on the day, the winds were true. There were severe winds here. In fact, if anything, in the film, they didn't make it, they just weren't able to make it as violent and dramatic as it was in real life. They just can't. You can't really manufacture a big windstorm when you're filming making a film. So, if anything, the windstorm at Parkes was even more severe than depicted in the film. But they did get the general story correct, in that Parkes received the best and the bulk of the moonwalk TV, relaying it to 600 million people worldwide. I always joke that, the astronauts may well have been on the Sea of Tranquility on the day, but it was well and truly the ocean of storms at Parkes on that famous day. But it's a great film. I love it very much, but then again, I'm biased, I guess. So, but always keep in mind that it's not a documentary. It's a motion picture that took some artistic license and amalgamated some characters to simplify the story, and so on. But Australia's involvement was actually extremely involved and critical.
So, John, tell us about the reality. What was happening at the radio telescope in those crucial days and moments of man walking on the moon?
Parkes became involved in the Apollo missions in October 1968 when NASA requested its inclusion, specifically during the short few hours that the astronauts were on the lunar surface. So in order to prepare for that, meetings were held in early 1969 and so on. And on the original mission plan, Parkes was to be a backup to the big Goldstone antenna, the 64-meter antenna at Goldstone. The lunar module was to land on the moon at 6:17 a.m. on the 21st of July, 1969 in Australia. And then shortly after they landed, they were to come out and perform the moonwalk and so on, and then get back inside, have a sleep, and then take off. Now, the moon at Parkes on that day was not set to rise until 1:02 in the afternoon, around lunchtime. So the moonwalk would have been over by the time the moon had risen at Parkes. And so it was designed to be there as a backup in case there was a delay in the moonwalk or they had to take off early or whatever. But about 2 months before the mission, NASA decided that the astronauts would actually go to sleep first. They would land and then have a little sleep, 6-hour rest, and then they'd wake up refreshed and come out and do the moonwalk. And so the moonwalk was rescheduled to occur at about 4:21 in the afternoon, when the moon would have been high overhead of Parkes by then, but it would have set at Goldstone about 20 or so minutes earlier. And so Parkes went from being the backup to the prime receiving station for the television on the lunar surface. And so everything had to be suddenly duplicated. NASA always wanted backups for everything. And so the receivers were put in place, the radio receiving equipment, the processing equipment, the microwave relays, everything. And everything was ready to go. The astronauts eventually did land on the moon, right on schedule at 6:17. And then, and just when they were thinking of going, the NASA's plan had them resting, the astronauts decided that no, they're not going to sleep after all. They're just too excited. Neil Armstrong's heart rate was 150 beats per minute when he landed. There was no way they were going to sleep. The adrenaline rush and excitement would have just meant that they would have sat there awake for many hours and then come out more tired than they were. So they decided to come out early. And as a result, it looked like, oh no, it's all going to be over before it even rose at Parkes. The moon had risen at Parkes. And so suddenly Goldstone assumed the role of being the prime receiving station. Now, the astronauts took their time in preparing to exit. They donned their spacesuits and everything and slowly depressurized the cabin. So by the time they were about to emerge, the moon was getting closer to its horizon. The telescope's horizon is 30 degrees above the true horizon. For various reasons, we can't tip all the way to the true horizon. So the moon was inching its way up, and it looked like that Parkes might actually get at least some of the moonwalk as the moon rose. However, with the dish fully tipped over, waiting for the moon to rise as the hour got closer, a violent storm hit the telescope. A squall just struck the telescope. There were winds, and in fact, there were 2 sharp gusts of 110 kilometers an hour that slammed the dish back against its zenith axis pinions, causing the tower of the telescope to shudder and sway. The people inside were concerned. John Bolton, the director, held his nerve, checked the strain gauges to make sure everything was okay. And just as Buzz Aldrin switched on the TV camera, the moon just moved into the field of view of the Parkes Radio Telescope. But they were able to receive the signal simultaneously with their colleagues at Goldstone and at Honeysuckle Creek. And so at the beginning of the moonwalk, NASA released the pictures received from Goldstone to the world. However, the pictures were of very poor quality. They were upside down, very dark. You could barely make out anything at all. So they then switched to the pictures being received from Honeysuckle Creek, hoping that the pictures were better, and they were better. And so it was during that period that Armstrong stepped on the moon. When they switched back again to Goldstone, the picture had gone negative, so they switched back to Honeysuckle. and then back to Goldstone when they'd corrected it, but the pictures were still pretty poor. But when they finally switched to Parkes, about 8 minutes into the broadcast, the picture was so much better. They stayed with Parkes for the remainder of the moonwalk, and so the picture quality just improved. You can actually see the marked improvement in the TV when they switched to it. But throughout the entire moonwalk, the winds remained very high, and the telescope continued to operate well outside all safety limits. In fact, later on in the broadcast from the moon, it began to hail at Parkes, yet the picture did not signal, the TV signal did not degrade at all, and so NASA remained with the Parkes pictures. So thanks to the Parkes Radio Telescope, the world was able to witness that historic moment with the greatest possible clarity. And the signals from Australia, from Parkes, were relayed by microwave links to the OTC terminal at Paddington in Sydney, and from there to Houston via satellite and so on. And but before the signal went to Houston, it was split off and sent to the ABC Gore Hill studios for distribution to the Australian networks. And consequently, because in Australia we didn't have to relay the signal all the way to the US and back, Australian audiences actually saw the moonwalk about 300 milliseconds before the rest of the world, or about a third of a second. And so we were able to see that. But the astonishing thing is that on the days leading up to the moonwalk, the weather was perfect. It was still no wind, very little wind, and everything was working really well. But on the day of the moonwalk, the storm hit, and in fact, those 110 kilometre-hour gusts were the highest wind speeds recorded at Parkes in the first 10 years of the telescope's operation. Quite astonishing, really, when you think about it. It's been we haven't had winds that high. We don't get winds that high at Parkes very often. And with the dish fully tipped over, it was a very critical moment. Yet we were able to receive those pictures throughout. So that really was an amazing achievement there in terms of that. And of course, the success of the mission was so great that NASA contracted Parkes to support all subsequent manned lunar landing missions, especially Apollo 12 and 15. And we weren't supposed to track Apollo 13, but because of the accident, they were called in at very, very short notice. And because of its large sensitivity, we were able to track the spacecraft, pick up the extremely feeble signals, which were 1,000 times weaker than the Apollo 11 mission, and help save the mission from disaster. So, the events at Parkes were really quite amazing on the day, with the wind speeds, the moonwalk beginning just as the moon rose at Parkes, the switching with it, and then the sudden improvement when they did use Parkes and so on. So, really was an amazing day.
I think it's something, John, we should all be proud of, and I doubt that Australians know enough about it. It's just extraordinary, the breadth of the support that we were giving to NASA in that description you've given there. It really sums up to me the collective effort of the Apollo program, because it was, as you say, it was an American initiative, but it was something that brought people together all over the world. It's just a really good example to me of the importance of this combined effort, wasn't it? That it wasn't just America on its own doing these specific things. There was people all over the world who were contributing to this effort to get man to the moon. That's
right. In the US, at its height, there were 400,000 people working on Apollo. 400,000. Imagine the cost. It's incredible. In fact, the cost of Apollo by the end was over $25 billion US dollars at the time. Now, in today's money, you're looking at that would be around 500 billion, depending on how you count the money. So it's an incredible, $500 billion is an incredible amount of money. But it all began in 1961 as a Cold War exercise, because 1961 was the critical year. Everything went wrong for the new Kennedy administration. When Gagarin was launched in April the 12th, just 5 days later, there was the Bay of Pigs disaster, where the United States was humiliated by Castro and his forces in the attempted invasion and retaking of Cuba. In June, there was the Vienna summit between Khrushchev and Kennedy, where Kennedy was treated like a schoolboy and treated very poorly, and Khrushchev even threatened war. In August, the Berlin Wall went up. In October, there was the standoff, military standoff in Berlin that almost led to war also. And then at the end of October '61, the Soviet Union detonated the largest ever nuclear device, 60 megatons, in the Tsar Bomba test, which was quite hot. So the Cold War was really heating up, and the entire Apollo program should be seen in the light of the events of 1961. And the Kennedy and his administration resolved that they had to do something to stand up to the Soviets and to demonstrate the superiority of of free countries and the democratic processes and so on. And so one way of doing that was to initiate a program that would demonstrate how the economies and how free people could combine and work together to achieve what would previously be thought of as an unimaginable goal and an unimaginable achievement. And so Kennedy came up with his administration came up with the goal of landing a man on the moon within the decade. And the reason they chose that is because in those days the Soviets had much bigger rockets. They could lift heavier objects, put bigger things in space. So if they had chosen a race to, say, put a space station in Earth orbit, the Soviets likely would have beaten them. Whatever they came up with, the Soviets, with their advantage in heavy lift rockets, would have beaten them. But in order to get to the moon, both sides had to develop entirely new rockets that were orders of magnitude more than what they had. And so by choosing a race to land a man on the moon, it put the US on level footing with the Soviet Union, so they could start even and then get going from there. Kennedy had the slight advantage in that a lot of the technology had been developed in the Eisenhower years. The F-1 rocket, the Saturn series of rockets were under development. The big engine, the F-1 engine, was being developed. The development of computing, of fuel cells, and all these other things had begun in the Eisenhower administration, and that's why Kennedy's advisors thought that, if they could start now and with sufficient funds and with a crash program that was of national significance, there was a good chance that they could actually beat them, which is why he chose that. Now, over the years, as it developed, in 1961, the support was in Congress was very high because they felt something had to be done. However, as the years went by, especially after October 1962 with the Cuban Missile Crisis, people started to have second thoughts about it, and support for Apollo began to wane. And in fact, in 1963, the Congress cut NASA's budget, and it looked like the entire Apollo program would be cancelled, would not be able to be achieved in the time frame. However, very unfortunate, but for the United States, but for Apollo, it was a bit of luck, I guess. President Kennedy was assassinated, and in the national mourning that followed, the Congress reinstated the full funding for the Apollo program and they turned Apollo into a monument to a fallen president, and they felt that they had to continue with it. And so Apollo was able to continue in the time frame given. Initially, Kennedy wanted before the end of his second term, but his advisors said that's a little bit too tight. Let's just say the end of the decade. And then he asked, well, when's the end of the decade? Is it 1969, end of 69, or 1970? And his advisors said, keep it ambiguous, because if for some reason they are delayed and they have to go to end of 70, then they can still claim they did it by the end of the decade. And so Apollo progressed, but at no time did it ever have majority public support. There was only 1 2-week period in the middle of 1969, July 1969, where it had majority support. That was during Apollo 11. And even then, it was only 53%. So because people realized, the mood of the country had changed. What began as this Cold War agenda in 1961 to stand up to the Soviets and do something, by 1969, the country itself had changed. The entire culture was different. It was no longer this gung-ho thing. The United States was mired in an unpopular war with mounting casualties. There were social upheavals throughout the country. There were assassinations and all sorts of things happening, and riots in the major cities, and it was really quite depressing. And so what began as this Cold War thing in 1971 had morphed totally by 1969. The country itself had changed. And so by the time that Apollo was realized and Armstrong planted his left boot on the moon, it was seen not as a big American effort, it was seen as a human effort. It was something that all humanity became part of. When the plaque the astronauts unveiled on the moon read, "We came in peace for all mankind." It didn't read, "We beat the Soviets," but it was, it was seen by all of mankind as a major human achievement. And it's in that form that we remember it Apollo now. We see it as a great inspiring human achievement, a demonstration of what human beings can do if given the will and the resources and the cooperation to do it. And even today, the old saying goes, if we can put a man on the moon, why can't we fill in the blank, But Apollo was a project that could be achieved provided you gave enough money for it. And many people have argued that Apollo was a program that rightly should have occurred in the middle of this century. But Kennedy had dragged it from the middle of the 21st century, dragged it and plonked it in the middle of the 20th century instead, because of in 1961 of the Cold War scenarios that were there, the dire situation that the United States saw itself in and needed to do something. Much better to do something without having to fire a shot and achieve unity than have the Cold War heat up, as it almost did in October of '62 in the Cuban Missile Crisis. So I always say, that when you go out and have a look at the moon today and look up, it's a very different moon to the one that people would have seen in 1961, because the moon we see today is a moon that's been touched by man. And that has coloured everything we've done ever since. We live in a world today that knows that people have been on the moon. When we and that affects people, it affects your thinking and your outlook and so on. It's inspired generations of engineers and scientists and astronomers and so on. And so it's had a deeply profound effect on people. And it's in that guise that it's remembered. It's seldom remembered as a Cold War phenomena, a Cold War reaction, but it's always remembered nowadays as an inspiring, uplifting event that was achieved on behalf of all mankind to show the best of us. It may have started with the worst motives, but it certainly ended with the very best.
Thank you, John. It's been a really wonderful insight into not just the program itself, but also Australia's absolutely crucial role in this incredible story. And I'm sure this will encourage more people to learn about Parkes, the Radio Telescope, and Australia's really important work in the whole space program. So, John, thank you so much for your time.
It's been a pleasure, Matt. And I look forward to people visiting the telescope, and they can come and see the great instrument themselves here.